Good, excellent, thank you. Apologies again to people who I'd again marked you down on my list for next questions. We don't break, we move smoothly on to the next item in this session. In fact, before our very final session of discussion, representatives from 8 leading engineering schools in the United States will make a special announcement about a new educational opportunity designed to advance global collaboration and prepare international graduate students to address global grand challenges. So I'm pleased to introduce Tomcat Sulis, Dean of Engineering at Duke University, who is accompanied by his colleagues listed on the slide up on the screen. Tom, fantastic.
Thank you.
Over to you.
You guys can stand or sit, whatever you'd like. It's a tough act, but an inspiring act to follow, I guess I would say. One of my faculty advised me when they learned that we would be following Bill Gates, but not realizing that he was only on screen, to look around the podium for something he might have dropped that would help fund the program we're about to announce. But I guess it won't help in this case. But let me introduce my colleagues here. We have Professor Rick Miller from Olin College, the president of Olin College, and Dean of the University of Southern California, Yanis Yortsos, Christine Ortiz, Associate Dean of Engineering at MIT, Eric Bray, Associate Dean of Engineering at Illinois Institute of Technology. Unfortunately, Professor Iswarakis is unable to join us from Caltech. I think he's still in the warm weather of Pasadena. Professor Robert Matheson, principal you met yesterday of the NC State Early College STEM School. And Professor Santosh Devasya, Associate Dean for the College of Engineering at University of Washington. Thank you, ladies and gentlemen, for joining me here. It's quite an honor to be here. I'd like to thank the RAE, the NAE, and CAE for the opportunity to make this announcement. Congratulations to them. What a grand summit it has been. I want to add my thanks to the speakers, both the metaphoric rock stars of engineering as well as the literal rock stars who have made this event so inspiring. As we've been hearing over the past couple of days, the grand challenges for engineering don't respect geographic or disciplinary boundaries. Challenges like providing clean water and engineering better medicines to prevent pandemic disease cannot be met by a single nation or single field. As educators, we realize that the most powerful tools we have to tackle these challenges are the bright minds of our young people. And we had a nice introduction to that from Bill Gates, who said that his big advantage was having a young mind at the time that the microprocessor was new and unaware of the limitations of older technologies. The next generation of engineers will need to be empowered and connected across global lines to address the grand challenges for the 21st century. The outgoing NAE president, Chuck Vest, made this point very well when he said, and I think there's a slide on this coming, he said, as we think about the challenges ahead, and I don't know if I need to advance the slide. I guess I do. Yes. Okay. It isn't. It says next, but maybe I could get some help from the booth. As we think about the challenges ahead, he said, it is important to remember that students are driven by passion, curiosity, engagement, and dreams. Although we cannot know exactly what they should be taught, we can focus on the environment in which they learn and the forces, ideas, inspirations, and empowering situations to which they are exposed. In the spirit of providing these opportunities, the 8 American schools represented here today are very pleased to announce the launch of the Charles M. Vest NAE Grand Challenges for Engineering International Scholarship Program. The Vest scholarships are named in honor of Chuck Vest, whose leadership and championing of the Grand Challenges and the role of the engineering profession has been inspirational. And although we're sorry that Chuck couldn't be with us for this presentation today, I know he's watching online, and I just want to say to Chuck how much your example has meant to all of us here on the stage, and how excited we are to name this scholarship in your honor. And I just learned recently that a story that illustrates the kind of impact that Chuck Vest's leadership has had on all those around him. The funding for the scholarship at MIT will be 1/3 from the faculty of MIT, where Chuck Vest was the president for many years. So it just kind of shows you the the kind of person he is, and the feeling that we all have for him. Okay. The VEST Scholars Program follows on programs announced at previous U.S. summits, the Grand Challenge Scholars Program for undergraduates and the K-12 Partners Program for pre-college students mentioned earlier in the meeting. By contrast, the VEST scholarships are aimed at graduate students. They offer international graduate students the opportunity to spend a year at one of our 8 universities performing groundbreaking research to address one of the grand challenges, with all expenses paid by the host institution. It's something like a reverse of the Rhodes Scholarship, bringing initially 8 UK and international students to the United States instead of the other way for a unique graduate school experience. So why are we doing this? Basically 2 reasons. First, we hope that the VEST scholarships will grow and become a highly valued platform for international collaboration, specifically that students will carry the pollen of great ideas from continent to continent with them and back again, strengthening international relationships in order to advance progress in the grand challenges. But second, and perhaps more important, we hope to cultivate a community of VEST scholars, a network they will have for life, with a shared mindset to take on the world's most important challenges. I'd encourage you to learn more about the program. We're still unable to get the slide up on the stage, but there are posters at the information desk, and there's a website which is really quite simple, vestscholars.org. So I want to acknowledge there's a parallel opportunity that the UK schools are offering to international students to study in the UK and pursue grand challenges. So particularly US students, the VEST scholars aren't for you, but this UK opportunity is for you. It's at a slightly longer website, raeng.org/grand challenges, but the RAE website. Okay. I hope we've, sorry about this, Chuck. I hope we've saved the VEST for last. Last in the sense that we may look back at this as a concrete, lasting outcome of the first Global Grand Challenge Summit. And as my colleague Rick Miller said, someday wonder how we ever did without them. Thank you, and please take a poster and let your students know to apply to vestscholars.org. Thank you very much.
Okay, well, we're on the last session now. If I could invite the panelists to maybe join me on the stage now while I introduce the final session. So this final session is a discussion led by a panel of rising stars in engineering and intersecting fields on how the Grand Challenges agenda can be used to drive change in the future. So I'll very briefly introduce the panel, and then we'll immediately go into the discussion. We have, from the far end, Yewande Akinola, who's engineer at Arup and current IET Young Woman Engineer of the Year. Jared Drummond, who is an MBA candidate at Oxford University. He'll begin his doctoral studies in mechanical engineering this September. Jilei Ho, who's head of Qualcomm research in China, and Dr. Eleanor Stride, researcher in encapsulation, ultrasound therapy, and medical imaging at Oxford University. Right. So I think rather than having the people standing up and giving talks up at the pulpit, as it were, I'll ask each panelist, I think, to briefly introduce themselves in turn, and maybe, once they've introduced themselves, to answer the following question. What is the key message that you'll take away from this summit? Do you want to kick us off?
Yes, I would. It's been amazing being here the last couple of days, the last 2 days. As a young engineer, once in a while you need a bit of a lift, something to kind of keep you going, keep you interested in engineering, keep you enthused about engineering. And I can say the last 2 days have definitely done that. I work as a design engineer for a company called Arup. And over the last 5 years, so straight after university, I've had the opportunity to see where engineering fits in developing countries as well as the developed world. And there's so much talk about sustainability in the developed world and providing basic amenities in developing regions. And you can see there's a common theme, it's about using limited resources to make lives better. So it's been amazing being here. It's been really, really good and useful. One thing I'm definitely going to take away, I work in building services, so it's all about designing water supply systems for buildings, if it's a 300-meter tower in China or a school in the countryside in the UK. And one thing I'm going to take away is the fact that we can probe our lives and the way we live and the way we interact with the environment to design better, responsive systems in our buildings. I think that is one thing that's come out of all the talks on biomedical engineering, all the talks on computing. I'm going to look at my computer in a completely different light now. Completely, it's not just spreadsheets. It's about data collection. It's about interpreting the data. It's about telling a story from the data that I collect.
Thanks, Yolanda. Okay, Jared, over to you.
So as has been mentioned before, my name is Jared Dunman. I'm currently studying at Oxford University, and I'm actually here because I graduated from Duke University in 2011 as a Grand Challenge Scholar, so I'm really excited to be here. My work mostly nowadays is on energy generation and distribution systems, both developing the technology and working to develop distribution systems as well and demand management systems. So across the board, looking at that kind of sustainability, resiliency challenge, and a lot of the things that were said here really resonate in that regard. One thing, a message that I will really take away from this is a more general message, I think, that the definition of an engineer is evolving. It's evolving in a number of ways, and a number of good ways. From an academic standpoint, I think we're really beginning to widen our approach, and we're blurring the traditional boundaries between disciplines. We're seeing, this week we've seen abalone used to create new materials. We've seen dresses, beautiful dresses, used to deliver catalysts to clean the air. And we've even seen digitization of the very building blocks of life. Those are really exciting things that are coming out of what's changing and how we're thinking and how we're moving our thinking. From a geographic standpoint, we're also evolving. Engineering is not necessarily just addressing the problems that are unique to your locale anymore. It's thinking about these very grand challenges that in many ways the same challenge manifests itself so differently in different contexts. In the developed world, we had a talk about developing healthcare systems versus developing disease care systems, and how do we deal with the problem of a disease care system that's focused on tertiary care versus healthcare systems and prevention systems that are focused on really lowering the cost and increasing quality of life. In the developing world, we have a very different problem, which is supplying very basic services. And so that's the same challenge, but it's very different in two different ways. And finally, I think, and perhaps most importantly, we're changing vocationally. We're starting to understand that increasingly often, while we're very good at solving technical challenges, solving those technical challenges is just the start of what we do. And to truly address problems like the grand challenges that are so enveloping in nature, we have to have a number of things. We have to have the tenacity and the patience to engage policy and politics. We have to have the ability to put together business models that are viable and effective for implementing the technical solutions that we devise. And finally, we really have to do on a social level what's necessary to make the general public aware and to kind of create the behavioral change that's necessary to address problems that affect billions and billions of people. And so I suppose to summarize, as engineers in the future, we're really not just going to be counted on to deliver technical solutions to technical problems. What I'm really taking away from this is that we're going to be relied upon to apply that technical knowledge to develop and implement holistic solutions that really deal with society's most pressing challenges.
Thank you. Okay, Julie Ho, over to you.
Thank you. First, it's a very honor to be part of this great event. Actually, I have attended a couple FOE programs from NAE and also joined it from NAE and CAE. So I'm glad to see a lot of good old friends here again as well. In terms of the key messages I have taken away, probably there are two aspects. In the first area, I think, to me, really reinforce one of the messages. I think the grand challenge itself is very sophisticated and dynamic. It's not just engineering anymore. It's really including all the science, policy, regulation, and the business areas. Also, I think the society probably need to take in a bit of more longer-term view, not just simply is a short-term incentive and a profit-driven, or even just a simply convenience-driven. Actually, I like one of the earlier speakers talking about you want to be a little more consequence-aware. So I think if a more general public can be aware of this, I think the whole society all getting a lot better too. The second aspect I want to share a little bit, actually, for myself, I hope it's also a bit shared for the general audience here too. So in a sense, people may know Qualcomm in general because mobile phone has been taken a lot more significant role in your daily life. Qualcomm actually is making the basically processor, baseband application processor inside your mobile phone. We probably take more than 50% of revenue of the chipset within the mobile phone. So in a way, we are in a very unique position going forward for a lot of internet technology evolution. From that regard, actually, I'm very surprisingly positive getting a message that a few things that Qualcomm is exploring from an initiative perspective actually are well resonant, acknowledged in this conference, because a few things we have been doing, I can probably just quickly touching upon. One is actually we are focused on developing sustainable technology, which are mainly in the energy area, for example. Things in terms of smart grid, smart living, and smart home. For example, one concrete example is what we do, we own the technology for both the power line and the wireless in home. So if you combine those, you can really build an intelligent and smart network for your home. So in terms of how to help you doing this energy saving and make people life quality better, I think we can do a very good part of that. The other quick example on this is actually Qualcomm also developing wireless charging technique for electric vehicles. For example, people may know about there's one of the biggest consumer electronic show called CES every single year in Las Vegas. This time, the keynote speaker actually was given by our CEO, Paul Jacobs. On that event, actually, he demonstrated how to doing wireless charging on an electric vehicle car. Actually, was getting very positive response from the community. So this is one aspect. Also, in terms of mobile healthcare and about the advanced learning, we talk about developing countries where actually Qualcomm is essentially doing those things in initiatives. We put in our effort and the resource behind, helping out Latin American, Southeast Asia, also helping out women initiatives to make sure they can getting more equal quality in a lot of the developing countries. So I'm just saying that's the second aspect I'm sharing. I felt very fortunate to be part of the event. I felt also a lot of Qualcomm has been doing has been very relevant in this summit. So very happy for that. Yeah.
Thank you very much. Eleanor, over to you.
I'm going to court controversy and describe myself as a vehicle designer and engineer. Sorry. The vehicles that I happen to work on are small enough to be injected into the bloodstream, and the reason for doing that is to deliver drugs more effectively to target sites. But the process that involved is still very much engineering of a vehicle. In terms of key messages, it's going to take me another week to process all the information that I've received over the past 2 days. I found it incredibly exciting and reaffirming to be an engineer. If I have to pick two, the first is redefining what I interpret by public engagement. It's not about giving a talk when you've done the work. It's about appreciating what the public needs at stage one and developing that feedback throughout the whole process engineering. Actually really understanding what's involved, what's needed, and what's acceptable. There's no point engineering a solution which is not going to be adopted because people don't like it. You have to get everyone on side. The other thing is harnessing the incredible power of engineering and the amazing developments that we've heard about in the past 2 days and targeting them correctly. I think one example, and I'm sorry it's almost become a cliche, but is energy. The technology is there for some of the renewable sources to be exploited and utilized, and yet we're still devoting our resources to, for example, fracking. And I think we need to think more carefully about how we direct those resources.
Thank you very much. Well, as they were speaking, I realized that in previous panels, even when the panelists only gave their brief introduction, we gave them a round of applause after each statement, and we didn't do that. So we just have to give a really big, yes, why not? Now's a good opportunity. Thank you. It's your faults as much as it is mine. So, I want to open up the discussion to the audience as well, and I want to maybe begin it by asking you all sort of one question. You mentioned that you wouldn't look at your computer the same way again. Can I ask you if any of you, or what would you change in your own work as a result of what you've heard here over the past 2 days? Go. Excellent. Thank you.
Building services, or the way I kind of describe the work that I do, is I create inspiring spaces for people to live in, for students to be educated in. And I mean, we're mostly always in a building, shelter reasons. But then buildings use energy. And as designers, we've come up with amazing ways of reducing energy, but it's all, it's hidden. It's in our integrated panel systems, it's, in risers. And I just thought, just from listening to all the wonderful talks yesterday and today, it would be great to bring all of that creativity, all of that sustainable engineering to a place where people can actually see it, can interact with it, can be inspired by it. So bring the art into engineering. So you go into open spaces and buildings, and you've got, art right in front of people that tell people how much water they're using and how much electricity they're using, something they can visually relate with. So there's a big word coming up there. I don't know, visual sustainable engineering. I don't know. Yeah, but that is what I'd be hoping to do when I go back to the office, actually. So my clients are kind of in for a bit of a
shock.
A bit of a shock. Yeah.
Thank you. Anyone else want to? Jared, yeah.
Yeah, I think there's a few things that I'll take away back to my work in particular, and one of them is that as a guy who's looked at energy for a while, and particularly in the context of sustainability, one of the questions you always ask is, how does this affect carbon cycles? How does this affect pollution? How does this affect resource scarcity? And those are all sustainability questions in one sense. On the other hand, one of the things that I really picked up on was actually in the last panel was the idea of balancing sustainability versus resiliency in our systems, because you can make a very lean, very sustainable system that is extremely vulnerable to shocks. And in many cases, if we don't design these systems effectively, those shocks are going to cause huge damages and huge problems. And so finding ways to design sustainable systems that are still robust to shocks is something that I think I'll probably incorporate a bit more into the way that I consider large-scale energy systems like combustion systems, solar systems, grid-scale systems, and thinking about how we make those things interact to form a grid infrastructure that is robust and yet is sustainable for the future as well. And I think another thing that I'll take is, right back to my own work, is the concept of synthetic biology, which is something that I knew existed, but certainly I think that the conference has emphasized the degree to which that is really a frontier in engineering right now. And it's something that if you're thinking about, even in my field, understanding how different gases combust, understanding how potentially biologically sourced fuels burn, you have to think about where those fuels come from. And now instead of thinking about, well, we have so many plants that exist and we have so much biological material that exists, you can then start to think about, well, how do I make the ones that I want? How do I work to build systems that are conceptualized from fuel design through combustion, through carbon mitigation and all these sorts of things. So taking synthetic biology back and taking that in the context of resiliency and sustainability is something that I think has really resonated with me.
Thank you. Anna.
As I mentioned, we're working on healthcare engineering solutions, particularly for drug delivery. As Bill Gates just mentioned, that's an incredible problem in the third world. I'm very privileged to work in a fantastically resourced leading teaching hospital where we don't need to worry about transporting the drugs, storing them. It's all done for us. And I think I'm going to take back the message that when we are designing our drug delivery solutions, we need to think about transferring them across the world and what that's going to involve in terms of their design.
Thank you.
Yeah, I guess something to share. Actually, it's a bit interesting angle because I'm working for a US-based company, but now I'm based in Beijing, leading the R&D center there. But I think something unique I can have a greater impact from my work is, as some of the early speakers has been talking about, the CO2 emission in China is a pretty challenging issue in general. Again, I know that the China government are already putting a very good initiative and effort trying to solving the issue in general. But I'm just saying from my humble little person, what I can do is actually we also sponsor the China some of the top schools on their research program. We're supporting 10 schools for their 22 programs currently. So what I can do from our perspective, probably for the future collaboration from funding perspective, we can think about a little more the angle on energy saving and sustainability technology development angles. So on those things, also I think on my side, we probably like to do a little more promotion about this kind of awareness in schools and also hopefully in some more public domain as well. Yeah.
Thank you. Well, I think you've all sort of touched on this. This question's come through from Birmingham. But maybe you might have something profound to add. They ask, what would the panel like to see as a single output from the summit that captures the essence of the summit and is a call to action for a wider audience to get involved with the grand challenges? Go for it. Just, okay, well, there's bound to be more than one, but maybe one at the top of your head. You've got a list. Oh, you're very well prepared. Well, just okay.
But if we just go for one, one thing that's come out of this is the fact that we need continuity in the work that we do. So we've got the Chinese Academy of Engineering here. We've got the National Academy of Engineering. We've got the Royal Academy of Engineering. All three bodies and all three academies are channels for innovation. So channels for innovation from the US, from China, from the UK, and we really need to create that forum. So whether it's in a website, whether it's in a newsletter we get every so many weeks or every so many months, a place people can come to and drop ideas, can receive assistance, business assistance, engineering assistance, and take these ideas back to where they see a need for it.
Well, you've worked in TV. You should be the face of this of the summit. Ellen, did you want to?
Do you want the short one or the? Well, the short one is, I think, not only do we need those three bodies, we need to have more politicians, more people attending this sort of summit to hear the fantastic stories and be enthused about it. And I think we need to take up the challenge of making engineering sexy. I think that's said it in a nutshell. That's what we need to do.
Absolutely.
I have a more serious subject.
No. Good. So let's open it up to the audience. Who would like to ask a question? So our first questioner there. Yes?
I'm always uplifted. Dave Sombrennan, Clemson University. I'm always uplifted by hearing young people talk about enthusiasm. I think we all like that. I would, though, like also, I think when I think about Jeffrey Sachs and what he was talking about on the first day, is to hear instead of enthusiasm or after, I'd like to hear beforehand, is sense of urgency. Maybe the panel can comment about that. Sense of urgency and then enthusiasm. Be a better order.
In that order.
In our current time.
Who would like to? Jared?
Yeah, I'd like to take that. In that To that point, I completely agree with you. Urgency is crucial. For the generation of engineers that trained me and that trained us, I know, for instance, in the United States, one of the big things that was that really caused a lot of people as a kind of a call to action was Sputnik. And then everybody looked up in the sky and said, wow, Sputnik's up in the sky. We should really get on this aerospace thing. And that made an entire generation of people really interested in aerospace engineering. And when I and a lot of my classmates were were growing up in the 90s, early 2000s, we were looking at the way the world was working and said, wow, this is really great that we have all this stuff. But if you told me that I was running my business, running my life out of a bank account that wasn't being refilled, in the sense that many of our natural resources are not being refilled, you start to think, that's not a great plan, that it's really not great planning. And so, absolutely, in the back of all of our minds, we understand that it's crucial that if we don't solve a lot of these issues, or at least get them to a point, a plateau where we can deal with them and slow down the processes of degradation and the processes of resource depletion and things like this, within our lifetimes, people after us are going to have a serious problem. So we're, hopefully I speak for all of us when I say, people in our generation know that. And that's, I think, one of the reasons that energy is almost a cliche, is because we all see that without that, all of the amazing things that we're doing in biotechnology, things that require refrigeration, delivery of drugs, storing drugs in the developing world, all of these solutions, they don't work without that energy. And so, again, it's close to my heart, but I think that is echoed across all the fields that we work on, and I think across, our entire generation as well.
Thank you. Yes, so second questioner, yes.
Subhash Mahajan, University of California, Davis. I have two comments. One is, we discussed innovation. Innovation is necessary but not sufficient for the advancement technology. To innovate and then take all the way to a product, I think Professor from Cornell raised that issue. There is a value of that. How do we deal with that? It's not just the money from venture capitalists. Small businesses in the United States create 60% of the jobs, but they have no access to the infrastructure for research. They can't go to the national labs. Overhead is too high, and universities don't return the answers in a time they need the answers, that duration. So there is a lot for us to do, and that aspect was not developed in this grant sum. Second thing is Mr. Gates, who pointed out material science is important. And there was no discussion, the role of materials in the development of technology. They are interlinked. Materials can be showstoppers of all new technology. I will give one example. That's the transistor. We knew semiconductors do exist, but we could not produce a transistor. There were too many impurities. There was work done to address that issue. So the interlink between materials and technology is very close. If we want to advance that technology, we have to advance the materials. And it can be done driven by technology. You develop materials, or materials are there, and you build technologies on it. But the latter approach has not been very successful. I can tell you buckyballs and carbon nanotubes, they are all there. But we are still trying to find applications for them. So
Thank you. Thank you very much. Did anyone want to comment on the comment? Or? Sure. Yeah, okay. Thank you very much.
I would completely agree with your second point, which is material science is crucial. I couldn't do my work without that. My team has a material scientist, a chemist, as well as a biologist and a mathematician in it. I totally agree with you, and I think it is for the engineers to say these are the materials we need and to work with chemistry and material science to develop them. Do you want me to address the first point as well? Or?
If you wish, the floor is yours. You're a panelist. I mean, you can comment.
I agree, and actually one of the things I would like to see moving forward out of this forum is a national or international discussion on business models and intellectual property. I think, as has been said several times, other areas, other industries have started developing innovations in that area which will unblock the system of allowing collaboration between small and big companies and universities to get the solutions through quicker, and that also addresses the question of urgency, which, I completely agree with.
Thank you. Our next question is, yes, you, yes. No, yes, with a yellow tie, if it is indeed yellow. Yes, that one. That tie. The wearer of that tie.
Can you put your hand up?
But you need a microphone.
I guess this is for Jamie Hestican, University of Arkansas. This is for young people because there's lots of deans in the audience here. And over in session after session, we heard that we need to get more young people excited, that this is their problem. We need to get more young people into engineering. And we heard from people all the cool stuff that they're doing. But I can tell you right now that a big portion of my performance evaluation on a yearly basis is not how many young people I get excited about in engineering. It's how much money I bring into the college. So I'd like you as a panel to tell the deans, the Dean of Purdue right here, Duke over there, tell them, one, how important it is, and then two, for what they want to know, is young people that are more up on social media and things like that, tell them a way that they could track it so that they can say, yes, I'm doing a good job on that. I think that'll inspire more people to do more work, which we all agree in this room is very important.
Thank you. That's a very good point. Well, in fact, it's almost a round of applause. Did anyone want to? Yes.
Yeah, I could do that really quickly. I was going to say to the deans, are you on Facebook? I mean, I've had the opportunity of going into schools and speaking to various age groups, and I remember one school I went into, and I thought, okay, how am I going to get these guys excited? So I did video games. I showed them clips from a TV series that I did. This is fun engineering stuff. And yeah, so I thought, okay, yeah, these guys are really excited. Yeah, they're all going to become engineers. And then somebody put up their hand, and I was like, okay, you got a question, thinking it might be an engineering question, like, oh, how did you get into engineering? And this girl goes, Miss, have you met Cheryl Cole? Does anybody know Cheryl Cole here? No.
Some people didn't know who I am was. I didn't know Cheryl Cole.
Okay. And this is what they see, So we're not dealing with, we're not only dealing with the misconception of engineers in the classrooms. We're dealing with the misconceptions of engineers in the homes of people in the classrooms. And it's something that we kind of need to deal with and, target from grassroots level all the way right to the top. And it's for engineers, deans of engineering schools to speak to kindergarten schools, to come together to develop programs that welcome parents and welcome, friends and families into schools, into universities, to say this is what engineering is about. And these are the fantastic engineers that our school is producing.
Thank you. Yeah.
My answer to the deans, and it has been several times, is if we don't get the young people excited, we don't get any grants in the end, because we don't have anyone to actually do the work. It's a very, very simple equation.
Yeah.
I think this actually gets at something that was mentioned a few times, in the sense that as an engineering community, I think we can. It's one thing to get kids excited in a way that schools can track. But I also think it's really important that if you've done your job, you can see that on a whole society-wide level. So if you've done your job, really making sure that people are excited about not just the discipline of engineering. That's one thing, the design, the mathematical understanding of how the world works and applying that. If you've done your job in making sure that kids are excited about realizing what challenges are facing them and really going after that, using their lives to address those challenges, I think that's a very serious thing that we'll be able to see in a number of ways. You can potentially track that in a number of ways, but I suppose one of the things that I would suggest would be, just content generation. As an academy, as people who do engineering, one of the things that we really could put an emphasis on is things like op-eds, TV spots on national television. When there very, very serious problems arise, like the bridge falling down in Minnesota, I remember. I was surprised that I didn't see commercials every other day. You see them for interest groups in the U.S. certainly. I was surprised I didn't see a commercial every other day saying, by the way, this isn't the only bridge that happened to, and this is something we need to not only fix but also get kids on. We need to get people designing these things and understanding how they work. And so it's been suggested that there's the potential we could do an Academy Awards of our own, and that's maybe a bit of a radical, suggestion. But the point there is well taken. Is that if we do things to get ourselves in the public eye and in the public consciousness, we not only create people who want to do engineering, but we also create a society of people who, even if they don't become engineers, almost more importantly, they understand the challenges and they're engaged with the challenges. And to me, that's something that if it happens, you won't need to track it. You'll know.
Thank you. Yes, our next questioner there. Yes, sir.
Hi, my name's Alistair Nottle. I'm from EADS. I just wanted to touch on something that Yuanda mentioned earlier, and that is that some of our greatest engineering is almost completely invisible. Take, for instance, the internet. All people want to do is go to Amazon and buy books on their Kindle. They don't necessarily want to understand how it works. Having recently become a father, I've found that there's a brilliant program on about 3 o'clock in the morning on the Discovery Channel called How Stuff Works. How do we go about making the massive achievements that we've made and are going to make, how do we make that interesting? How do we make it accessible? How do we show it rather than people just taking it for granted and assuming that when they click a button, something will work?
Thank you very much. I think it still kind of comes down to us interacting with the rest of the world. So interacting with the right industries, interacting with the media industry, and we have to do the work. Nobody is going to do it for us. We are engineers, we're most comfortable at our desk designing the amazing things that we design, but we have to kind of come out of that square and, call BBC, call, rock stars, pop stars, call Beyonce, and say, would you be interested in partnering with us? We have to. It's the way the world is going, and it does make a change. It does have an impact on people. So, if there's anybody here in the audience that's got any connection or any, with Beyonce, that'd be nice, yeah. or with the TV industry, with the Channel 4, BBC, we need to get the message across that we're engineers. We're willing to come out to help, and there is we need them to help us.
Thank you. Tom, yes, you're next.
I'd like to thank the panel for your perspectives. When the steering committee set the charge for this meeting, one of the goals was to try to identify what were the needs and opportunities for global collaboration in order to solve engineering grand challenges. And I know even at the young age of your careers, you've had significant global experiences, even cross-continent experiences already. And I'd like to know if you could share with the audience a little bit about those experiences, and in what ways do you think that global experience and global collaboration you now do is critical to your success, if it is, in the engineering you're now doing?
Julie, do you want to kick off?
I probably can share some of my perspective here. Actually, I'll probably more just talk about our Qualcomm, how does the R&D center work, so probably can address your question to some extent. So the way we do is we have a corporate R&D which is sitting in our headquarters. But under that, now we actually have 8 to 9 R&D centers globally, distributed all over the world. So, for example, the one we have in China, the reason we have there is exactly for the reason because China become our largest revenue contributor. So then there's a great, a business reason to do that. Also, we have a huge talent pool in China. I think for all the reasons, I think now we're doing a lot of R&D. And also, the way we're doing now is because we have a great assets of customers in China, our OEMs, infra vendors, operators. So the way we do is we usually collecting a lot of key requirements. And then we will feed back to headquarters when we decide, based on the nature of the work and which are the more naturally happening in the headquarters or some should happen locally. But either way, we all require very close collaboration with our customers. And in many cases, actually, even with polling schools, there is some situation they may be in better position to help us. So I think the way our R&D center located in China, to some extent, is basically address the kind of things you're talking about. Actually, we are building our base, and we believe we are on a good path going forward, doing more in China too. So, yeah.
Thank you. Anyone else want to add to that? We had a question from the lady there. You did, yes, you did have your hand up, and I took note, even if you'd forgotten I hadn't.
It's perhaps not so much a question, but since Purdue University was singled out, I do want to make a note that universities play a huge role in this. And one of the things I'm enormously proud of being the dean at Purdue is that we, in fact, created the first freshman engineering program in the country to make it easier for students to enter engineering. That was over 50 years ago. We had the first women in engineering program in the U.S. We're the founding site of the National Society of Black Engineers, or NSBE, which has a conference that engages about 20,000 students every year. Founding site of the EPICS, Engineering Projects and Community Service Program, which currently through both EPICS and partnerships with IEEE runs about community-based engineering projects with both college and high school students at about 200 locations around the world, and also created the first Department of Engineering Education. And so there's a huge role for universities, and we do recognize our faculty and staff who are engaged. We've grown our engineering enrollment by 20% over the past 5 years. We have another 10% coming up over the next couple of years. And so there is an enormous role for universities in this, and we're proud to be one of the ones that's doing it.
Thank you very much. So, gentlemen, yes, there. Yeah.
Thank you very much. My name is Paul Streletsky. I'm a visiting professor at Manchester University in the UK. It's been a stimulating conference, but I feel a little bit shortchanged. I think as engineers we may have let ourselves down a little bit here, and I'm interested in the panel's view, which is there are supposedly 14 challenges. I've heard a lot that stimulated me. I've learned about genome sequencing and things I didn't know, but I don't know where we stand on making solar more affordable. I don't know where we are in giving everybody clean water. And I think the global challenges should be a little bit more engineering driven with a chart, and it shows our progress, and next time we show another chart and we show our progress. And otherwise, if you don't measure it, you don't get it done. That's the ethos of an engineer. So this is it. So my question to the panel or statement is, or would like your input, is, which of those 14, you can't do them all at the same rate. If you wanted to pick one of those and we wanted to prioritize it for the next 2 years or something, what is it you'd pick, and what is the different thing? Because we're on a burning platform, and we've heard a lot about recruiting new engineers and so forth. We've got the team we've got. If we're on a burning platform, you can't go moan we haven't got enough engineers. So we've got the team, the leadership's in this room. What is it that you would want to see happen that burn the bridges, metaphorically, to get something done in these 14 challenges?
Thank you. Well, I think you've just had the honor of asking the final question, so I'll ask each of our 4 panelists maybe to answer and pick their favorite, their most important of the 14.
So I'm a water person, and that's kind of my thing. I've done some work in Southern Africa, and so you go there and you give them that great engineering innovation, and then you go back 2 years after, and it's all kind of gone, non-existent, gone. And you start to ask questions, all that effort, where is it gone, why isn't it continued? And the answer is there is no business model to support the engineering. So there's no business, decentralized, local model to support the engineering. No sanitation businesses to support all of the infrastructure that you've given them. So what I would really, really, really like to see, or the support I would like to get, is in a group that would give the expertise, offer expertise to people that go out to African countries, to Asian countries, the ability to equip the locals with a business model and understanding of how they can make engineering work for them.
Thank you. Jared.
I will echo a bit of that and add a bit to that. In my view, from a very basic challenges standpoint, the ones that resonate with me are the most basic ones. So to me, it's water and supplying clean water and supplying energy in a sustainable fashion. To me, if we don't do those two things, most of the rest either don't follow or don't matter, because those are the basis of so much of what we do as a society. And they also have implications not just for quality of life, but for geopolitical stability going forward, for ensuring that kind of a set of peaceful societies that we have the world around. It's an important set of things to be able to provide. And I think that one of the most important issues for me in this area, and really understanding how move the dial forward, so to speak, would be not just understanding how new technologies work, developing an understanding of what technologies are out there, what systems already exist, and actually doing the very large-scale assessment of very large-scale infrastructure projects and which ones actually get closest to delivering the benefits that we hope that we supply by paying for them and by putting up a certain cost for them. Because right now, some of the work that I'm doing actually at Oxford is based around infrastructure projects and costing infrastructure projects. And actually, energy is one of the areas that we really don't have a great sense of. If you build X number of gas turbines or solar panels and you pay an X amount for them, how much are you getting? And in terms of allocating the very scarce resources that we have and that we as engineers are working to allocate appropriately, I would love to see a great deal of engagement on the part of the engineers here that have intense technical knowledge of those systems, to work with economists, to work with people who are on the ground doing these projects to assess not just do they work, but how much do they work in the context of what we paid for and what we allocated to them.
Thank you. Chile.
I think this is a great question you just asked. I think to some extent Qualcomm already engaged doing some area I just mentioned earlier. However, I think the more profound area, I think out of the 14 questions having listed, if you ask myself at this point, I will probably pick the reverse engineering of the brain. Because partly, I probably, myself as also as a group of company Qualcomm, we are a bit, big fan of supporting the first robotic programs. So you can imagine if you can understand the brain better, and plus, Qualcomm actually is a semiconductor company. If we can do anything in this domain, can build things, can really helping making a lot of good contribution in this area. I think it can open up the whole new world in terms of science, engineering, mathematics, and also biology and medicine. There are so many things can all coming up, I think, can make the society so much better. So I think that's my take.
Thank you. And finally, Eleanor.
I guess fundamental human needs are water, food, fuel, in that order, so that would have to be the order I'd want them addressed. But I really want to completely agree with Jared. I want to know, why haven't we adopted these fantastic renewable energy sources if the technology's there? What are the bottlenecks in the system, and what can we do to remove them?
Thank you very much. Well, that's it then. So please join me in thanking our four panelists and wish them luck for the future. Thank you. Thank you. Thanks, Jared. So while they leave the stage, the final thing to do is for me to welcome the president of the Academy, Sir John Parker, onto the stage to give a word of thanks.
Well, ladies and gentlemen, since I've appeared, we must be tending towards the end of what I trust you will regard as a very memorable summit here in London. Secondly, I want to say a very special word of thanks to all who have participated. And especially, I'm sure you would want me to thank our very hard-working moderator. And if I may be allowed to say, some of the most interesting people that I chatted to here were some of our young people. And I think it was tremendous to see them here, the young engineers of tomorrow. They were full of enthusiasm, and you, the speakers, and you, the panelists, have truly inspired them, and I'd like you to know that. Now, over the past 2 days, we've been exposed to an extraordinary combination of creativity, innovation, passion, and sheer intellectual horsepower. And as a businessman, if only I could bottle it, I'd make a lot of money. Now, we've discussed the problems and the opportunities, the risks and rewards presented by today's complex and interconnected world. And we have seen how engineers are at the center of efforts to develop new sources of energy, change the nature of medicine, turn consumers into makers, and create art out of artificial life. Make the infrastructure that we take for granted both intelligent and resilient. And we have also heard about the need to reach out to other disciplines, publics, and communities. Whether that's bridging the gap between medical researchers and clinicians, or tearing down the artificial boundaries between engineering and the creative arts. On building alliances between academia, industry, and civil society to promote real measures to alleviate climate change and to create the conditions for a sustainable future. Or persuading parents and educators that engineering is a creative, exciting, and truly fulfilling profession. Or making sure great research results in world-changing products and services. We have heard some radical suggestions, some compelling arguments, and some game-changing ideas. And yet at the same time, we have only scratched the surface in the time available. What impresses me most about the audience in front of me is its range and reach, from the most promising of our undergraduates to the most eminent of academics. From the UK, from China, and the United States, and further afield. All excited, all enthused, all making the links and the connections that will advance research, knowledge, and careers. At our academy, we want to preserve this enthusiasm and extend it to the broader engineering community. That is why we are looking to create a virtual resource for engineering thought leadership, an online center which will facilitate discussion and collaboration between engineers from all career stages and countries on the key issues facing our modern world. We will also be working closely with our sister academies in the United States and China, as well as our event partners, to harness and take forward the momentum and great ideas that have been generated by this summit. And I'm very delighted that the National Science Foundation in the United States and the Engineering and Physical Sciences Research Council in the UK have agreed to launch a joint call on clean water for all that has been directly inspired by this summit. It is also fantastic news that we have just heard that several US colleges are going to be running a Grand Challenge Scholarship Program. And we are delighted to be following up the success of our Grand Challenges short film competition with a Grand Challenge app competition, which you will be receiving information about shortly. Based on the interactions I have had with Summit participants, I have no doubt that this is just the beginning. We have enjoyed a truly rich conversation over these past 2 days, and I look forward to working with you all to make sure that it bears fruit in the months and the years to come, in the form of meaningful and transformational action. And I know that the Chinese Academy of Engineering, which will host the next summit in 2 years' time, is also ready to take up the challenge. So, ladies and gentlemen, may I wish you all personally every success in your endeavours, and above all a safe journey to your homes. And it now gives me very great pleasure to invite Dr. Song from the Chinese Academy of Engineering to say some closing words. Thank you all.
Thank you, Sir John Parker. First of all, I would like to congratulate Sir John and all staffs, all colleagues from the Royal Academy of Engineering for great success of this first summit. We really very much moved. You have invited so many great scientists, great business leaders, and renowned engineers to take part in this event. It is very much encouraging for myself, for all engineering communities. We have learned a great deal of knowledge, experience, and even definition of the engineering science. I would like to tell you, some years ago, science community defined engineering is a sector of applied science. I think the best description of the engineering, it is a combination, conglomeration of basic science, modern technologies, culture, art, and inheritance of our ancestors' survival skills. Oh, yes. The combination, harmonious combination, made the engineering science, as before people called it applied science. I frequently heard basic scientists, they call asserted basic science is driven by curiosity, what they say. So there are different opinions. But engineering science is driven by human survival and progress in the future. I was very much stricken by a statement made yesterday by Professor Jeffrey Sachs. He demanded engineering science should try to find a new way for societies, for nations, for mankind to go forward. We should open, reclaim, and pave a new way to lead the politicians and the government to follow. Or that his word is striking for me to hear this kind of demand and definition. If we look back, a number of great engineers, they led the way. They transformed the society. They created new way, new industry, as our beloved Bill Gates did. So I should give you, everybody, the promise to continue this spirit to prepare the next summit in 2015 in Beijing. I thank so many scientists, engineers, all the heroes took part in this event. We hope in the future, 2 years later, we will you will come to Beijing and take part to make it more active, more creative, more encouraging for our would-be next generations of engineers, scientists, and so forth. My colleagues would do our best. We are confident because we have very good helper, advisor from Royal Academy of Engineering and from National Academy of Engineering from US. So we have solid, strong partnership with them. So I don't want to take very much time. I officially invite all of you to come 2 years later to locate a newly emerging developing countries. Thank you.
Thank you very much indeed, Dr. Song. Just one final thing. We're going to put up on the screen the slide which Tomcat Sulis talked about, which we didn't have, which it has the details about the website of that new engineering scholarship. And my final remark is really to say thank you to all the staff of the Royal Academy and of the IET for making this 2 days run so wonderfully smoothly, making my job a lot easier. So I think they deserve a round of applause too. And thank you all, and have a very safe journey, however far.